Good afternoon. The time is 3 minutes past half. So this session is going to be on time. We are all going to put on our running shoes and get to the point as fast as possible. So, welcome to this session on data mapping with AI. My name is David, and we are just going to start right off with my Swedish colleague, Frida. Now, Frida is a project manager at the Swedish food department, and she's been working in this role and with EFSA come on reporting for 15 years. Is it working? So Frida is going to start us off with talking about a tailor-made activity which Sweden did over the last year. So welcome her, and please go ahead.
Thank you. Good afternoon again. As David said, I am Frida Broman from the Swedish Food Agency. So let's start with the data mapping tool pre-study. This project was initiated by the advisory group on data as a tailor-made activity, and the mission was to investigate the challenges that the member state face when they're translating their national data format to SSD2. We were also, within this project, supposed to propose an AI tool for making this transition, the transformation, easier. And our goal during this process was to find a way to make the data mapping easier, and so the data reporting also will go smoother and faster and easier. Our approach, we set out to understand the challenges faced by the member states by doing this transformation. And by doing that, we were engaging Swedish colleagues, Danish colleagues, and German colleagues. And also we involved Malta as an observer in this project. We did a series of workshops and meetings, both in-person meetings and virtual meetings, to find out the requirements and challenges. Yes. Our research yielded several crucial findings. The most outstanding or striking revelation was that the data mapping isn't actually the biggest problem for the data providers, but finding the correct term code or the SSD code. Isolating this core issue, the accuracy of term code selection, was a pivotal moment in our pre-study. We realized that while data providers could generally structure the data correctly, selecting the appropriate term codes from the EFSA's extensive catalogs was a significant hurdle. This insight shifted our focus from general data mapping to mainly addressing the term code selection process. The struggle with term codes is multifaceted. Data providers often grapple with navigating through thousands of potential term codes, interpreting the nuances between similar codes, and ensuring consistency in code selection across different data sets and over time. And as well as keeping up with the updates and changes in these catalogs. This challenge not only slows down the data submission process, but also impacts the quality and comparability comparability of the data received by EFSA. So our key insight emerged from this struggle. We made the realization that large language models could be leveraged to address this specific challenge. We found that large language models, when properly trained on EFSA's term catalogs and contextual data, could significantly improve the accuracy and efficiency of term code selection. This insight led us to propose an AI-powered tool that focuses primarily on assisting with term code selection. And by integrating advanced language models and embedding techniques, we can create a tool that not only suggests appropriate term codes, but also learns and improves over time. And with that, my time is up because we have someone here that's better with the tech issues. So please welcome David.
Yes, so I'm having a bit of a dual role here. Now I'm going to be David, the project sponsor. So thank you, Frida. So the project started and we had this idea. We needed to build this flow or this tool. How can we help data providers transform their data into EFSA standards? And the basic insight was that mapping data was really not that hard, but finding the right code, that was almost impossible. So by focusing on that, we proposed a solution like this. So this is all about finding the right codes. And this is the proposed flow. Now, it's important to actually understand that this is a pre-study. This is where we have done some basic proof of concept. This is not a working tool, and I must disappoint some of you. I'm not giving a demo, because demos always fail, and that would just send the wrong message. So this is in theory. We have some proof of concept videos to share, etc. But we are going to talk about how can we find the right code. And as someone said earlier, you always want to change the slides the minute you are showing them. Because we are going to talk some very basic stuff that has been covered, but I'm still going to do it again. So how does this work? Well, it works in three parts. It works with embeddings, it works with a source of truth, and it works with large language models. So I must explain what is the first part, embedding. So embeddings are basically just taking a text, a string, and making it into numbers. So by doing this, we can do some basic math on these numbers. So we can take a number of words, we can give them numbers, and then we can compare them. This is using embeddings to find stuff on the most basic level. This is how we can make sure, or how we can find out that these words, all the leaves are brown, is not only a lyric from a song, it's also a bunch of words that means autumn or is highly found together with autumn. Remember this, because this is like the basics of how this works. The second part is creating a source of truth. Because when we make these embeddings, we use the data EFSA has gathered. By using the EFSA formerly known as catalogs, now known as terminologies, I believe, together with guidance, documents, and other sources. For instance, the Samte pesticide database. We take all these things and put them into one database, and we add numbers to them, and that is our embeddings. So by doing this, we can make a source of truth. So the source of truth is made by embeddings, metadata, and context. By having this model, I learned yesterday that some of these terms are not called properties as I thought, they are called attributes. So I'm going to try and use the right term here. These come from EFSA. EFSA has done a very good job of making, I wanted to say catalogs again, dictionaries. They have made these dictionaries about the terms used in the standard and added a bunch of useful metadata to them. So we have the terms, the names, which we then embed into numbers, and we have the metadata. Now, the third part, the glorious part, the large language models. In the first week of this pre-study, we try to train our own models. We try to make a small language model. We try to use machine learning. We tried a bunch of stuff until we randomly just thought, hey, what if we just asked ChatGPT? And it totally blew our mind because it was so much better. So these large models were much better than our specialized trained model, which in a way was kind of disappointing because it was fun to build these models. At the same time, you need to take the best path. And the best path for us was to use existing large language models. So how does it work? Well, it works by building a prompt. First, and I understand that this is really small text, and I'm not going to read all of this, but basically the first part is being a very specific. Given this search term and all this context, so setting it up, instructions. We want to know the term for this, and this is going to be based on all these attributes. Then we give it, in this case, we say that, so this is based on params, we say that compounds can be all these kinds of things. You need to look for synonyms, you need to look for trade names, you need to look for alternate scientific names. So we give it the first sort of basic question, then we give it some very, very specific instructions. And then we add the result from our initial embedding search with our metadata. So we have all these three things, and we combine them into one large prompt. And if you want to know how large this prompt is, it's about 7,800 tokens, which doesn't say much, but it's large. And we send this to the model, and we get back an answer. And the answer is in about 80 to 85% the right answer. This is, of course, based on the quality of our source of truth. If the source of truth is wrong, the answer is going to be wrong. And as you can see in this prompt or in this answer, we give the answer, but we also give a reason why. Now, I had a very interesting question yesterday. What if the term code is right, but the reason why is wrong? Then I say, well, we are just looking for all the term code. So, but this is an interesting issue. Should you trust the reason? Should you trust the term code? This is the pre-study. We don't have the final answers, but we have built it to find the code, not the reason why. So this is the whole flow. We build a source of truth in a pre-processing stage. We ask the question to our database, which gets this list. The list together with the metadata is then sent to the large language model. And as you can see, we are actually using more than one model. We have been using between 3 and 6 models. So getting between 3 and 6 different answers, and then sending those answers to sort of a final model has turned out to be the absolute best way of doing this. Because that last model, which I call the judge, on the right here, the last model is the preview of the latest ChatGPT model, or the OpenAI model 01, the one that has reasoning. That has given us a lot of really good answers and some really, really interesting insights. And that was our presentation on the pre-study. So I'm going to thank myself. I'm going to thank you. Yes. Can I see the note again, please? Sorry. Yes, yeah. So the next speaker, which name I can't pronounce, Guillaume? Sorry. So Guillaume is a project manager from the Paris Institute of Technology, and he's here to talk to us about a tool using a deep learning algorithm to translate raw description of food matrices into standardized descriptions links to the food X2. Please welcome Guillaume.
Okay, thank you. Okay, thank you, David. Hello everyone. I'm going to talk to you about a tool that was designed to help us standardize some food descriptions. To explain you the table of contents, I'm going to talk about the problem that we faced and how the project was born from this problem. Then we're going to have a look on the data readiness to do this project, how the model was trained, and the results. So first, an introduction to the problem as we faced it. So I'm part of the chemical monitoring network. And in this job, I have to transmit data to, we have to transmit data to EFSA. So the data we have to transmit are made by the French Ministry of Agriculture, and we have to transform the raw data that we receive into the standard sample description 2. That is the format we have to use to transmit the data to EFSA. And when it is done, and after a quality check, we transmit the data to EFSA. Part of the data we have to transform is the raw information about the sampled and analyzed matrices. And this has to be coded into FoodX2, which is a complex language. And this part of the job is quite time consuming. And so we try to find ways to reduce the time we allow to this task. Why is it time consuming? Because of the complexity of the FoodX2 language, and also because of the diversity of raw information that we can get. So for instance, you have an example here about hen eggs, and you can see that there are many, the order of the information is not always the same. There are many useless information in the text. So first system that was implemented is to standardize the raw text we receive. So before we developed this project, we were standardizing the text, and then it was coded into FoodX2. Why was it done this way? It's done to limit the number of FoodX2 codifications we have to make. For instance, here, 2 raw descriptions are linked to only one standardized description, so we have to do only one FoodX2 codification. This systems allows us to reduce the number of FoodX2 codification we have to do, but it adds a step of standardization. The project I'm going to talk to you about was born from this situation. The objectives were to reduce the penability, work faster, and allow the process of an ever-growing number of data in the same amount of time. Reuse what has already been done, and ensure that the method is user-friendly, because we are not all informaticians. The means we had at the time was to develop a method that simplifies the attribution of standardized text from a raw text. And to do that, we used the material that was already available, meaning the previously established links between raw and standardized descriptions, the architecture of our storage to help us being more to have more automation in the process, and our coding skills in Python. So the purpose of the project is that when we receive some raw text, the model is standardizing it, or it's proposing a standardization, and then we have to check if it's correct or had a correction by ourselves, because we cannot rely completely on if the model will be accurate. And then, if needed, we have to code the text in FoodX2. So we use the already existing links between raw and standardized text as a learning database for the model. To do this project, we chose the transformer model, and I'm going to explain to you why. First, we had to define the task that was done during the standardization. To do that, the first thing to do is to remove all the useless information. And then the text is organized, so the descriptors are always in the same order. And we have to harmonize the text too with the handling of the synonyms, for instance. So it's about cleaning and structuring the information. And in the field of natural language processing, this is a sequence-to-sequence problem. And at the time, the transformer model seemed to fit very well this task because of the attention mechanism, which is original of this model, and that allows the comprehension of words together, even if they are not side by side. And it's a model that was designed for translation, so it seems to be a good fit. After the prediction of standardized text by the model, we have to propose a match to the user. And to do that, we had to develop a matching methodology. So first, we post-process the predictions by removing the duplicates, the small words, and rearrange the words to ease the comparison with the already existing data. And then we establish a score, which is the proportion of common words in the two texts formed in the union formed of the distinct words of the two texts. So for example, if you have a prediction which is dried fig in pieces, and you compare it to other already existing standardized text, we will have a matching score of 1 for the same description, and 2 out of 7 for dried fig packed in plastics. So we choose the highest score to propose it to the user. So now that we have the methodology of proposing standardized descriptions, we try to make it user-friendly. So the first task was the conception of the model using Python, and then with combining it by training the model to the data we used to train the model. We produced the model. And then we developed some other Python scripts to help us use the model and the data that was already existing to compute a score. So when raw text is processed by the script, there's a proposition of standardized text that is as an output in an Excel file because it's kind of user-friendly. And we decided to wrap all of this in an application. So when a user wants to standardize some raw text, the user has to choose the text to standardize. Then the user has a step to do, which is to validation or to add a correction to what was proposed by the model. And then the application gives out two types of information: the standardized text that has to be coded into FedEx2 if there was some addition made to the database that already exists, and the links between raw text and standardized text that will be added to the database of links. And so it will improve the size of this database. So I described to you the project, and now we're going to have a look on the data readiness on the data that we had available to train the models, and why it was in good shape and helpful. So first, I'm going to describe the data preparation. So we use the data available, meaning the links between raw and standardized text that had already been done during the previous data transmission campaigns, and this data is ready to be used to train the model because it's the task we're going to ask the model to do. But with limited IT resources, we decided that we needed to simplify the task as much as possible for the model. And so I'm going to show you how we did that. First, we did the first step of data completion consolidation. As you may know, FedEx2 is a language that is evolving each year with the addition of new descriptors, and so we had to go back to the old links established and try to update these links with the addition of the new descriptors that were made. So that's the first step, to harmonize all the data. Then we added a step of pre-processing the data that we go back to later, but the goal is to simplify the problem as much as possible by remove all the useless information that we can using regular expressions. And then we looked at how the data will be splitted for the training to help the model learn the best. So first we decided to divide the study in two parts, one for food and one for feed, because it seems to be a good idea as the data is really different for those two domains. And then we decided on a strategy to help the model to learn by ensuring that the data is correctly distributed during the training of the models. And I will go back to that later too. So now about the pre-processing of the data that we did. The goal is to reduce as much as possible the complexity of the problem for the model by reducing the size of the vocabularies, so the source vocabulary on one side and the target on the other side. So I'm sorry I led the examples in French because this method is strictly adapted for French language. The first part was to remove the accents and special symbols. Then we lowercase everything. We remove some specific patterns. So, for example, we removed the numbers that had no meaning in the description. We root to remove all gender marks, for instance. And then we vectorize the text. On the side of the targets, we did lowercasing, removing of brackets and gender marks, and then we vectorize it. Now for the splitting of the data for the model training. When trained, the model is very sensitive to how the data is splitted. And so we decided to as the purpose, the final purpose is FoodX2 codification. The standardized system was created in regards with the FoodX2 codification. So we decided to represent each base term at least once in training. So first we chose data split for the training of the model of 80% in training dataset and 20% in validation dataset. And then during the search of the best hyperparameters, which I will go back to later, we chose to do it by cross-validation. So it gave us 5 folds for each training to respect the 80%, 20% proportion. So cross-validation is a method that allows us to have an evaluation of the model performance that is not that dependent on how the data is splitted, or less dependent. As I was saying, we splitted the data according to how it was associated with a base term. So if a base term is associated, only with one description, it will always be in the training data set. Between 2 and 4, it will always be in training and in validation, and the rest is randomly splitted. And above 5, it will be splitted with an equal repartition as much as possible. So there's always one in training and one in validation dataset. Now we'll have a look at the model training. So the first part is to look for the best hyperparameters. So the hyperparameters can be understood as the external configuration of the model and the training parameters. And all of that has an influence on the performance of the models. So here you have a visualization of a simplified structure of the transformer model and the choices we've made for the training in terms of learning rate, dropout, optimizer, loss function, and early stopping. And the batch size, so we decided to act on 3 parameters, hyperparameters, which is the batch size, the embedding size, and the number of layers. And we did a grid search on the following modalities that you can see of these parameters. So we tried each combination possible of these values for the hyperparameters. When trained to select the best hyperparameters combination, there's a need to evaluate the model regarding the task using the prediction on the validation dataset. So on the overall prediction of the validation dataset, one row, one row score will be the percentage of perfect predictions. But we also decided to to design a score specific for the task. This score is composed of two parts, one on the target and one on the prediction. And it represents the proportion of words from one in the other, or found in the others. And then we compute the harmonic mean of the two parts that I just described. The goal to do that is to have a score on each set of prediction and targets. Then for each hyperparameter combinations, we have training that has been made on each fold of the cross-validation, and we compute the mean score of the global score I just presented. On this series, we compute the mean and the standard deviation, and then we compute the difference between them. This allows us to have kind of the worst model with this configuration, performance, and then we are looking for the higher score of this worst model. So we are looking for the best of the worst, and we get the results on a grid like that. So here you have the results for the different studies in food and feed. It's not really meaningful, but then you have to train the final models when the best hyperparameters combination is selected. So to do that, we use the whole data set and we split it again in the proportion that was decided, meaning 20 in training and 80 in training and 20% in validation. And if we have a look on the evolution and the performances of the model we trained. So first, on the data available, you can see that we have an evolution, a positive evolution of the number of data available to train the models, which is due to the fact that each year we produce more data. If we have a look on the model performance, you can see that the global scores are increasing, but it's not really meaningful. So I also put the percentage of perfect predictions. And as you can see, it is also increasing. So we can link that to the fact that we have more data to train the models, so it can be more accurate. As a result of this process, so as advantages and benefits, the overall process allowed us to reduce the penability during our work. We have a good feeling about the efficiency of the application. So it allowed us to process more data in the same amount of time. So we are happy with this situation. It allowed us also to reuse what had already been done during the past years. It is a system that is not greedy in terms of IT resources, and that is it's tailored to our needs, so it's quite good for us. And it's a tool that is maintained in-house, so we do not rely on outside partners. In terms of disadvantages, this model is specific to our problem and very dependent on the training data set, so it's not robust to new types of information. And the whole matching process with the interfaces of the application are specific to our team and our workspace architecture. In terms of perspectives, if we look in the future, we would try to look for better hyperparameter combinations and try to play with the other hyperparameters. Maybe modifying the prediction process will be more efficient and more robust. For instance, if we split the prediction in some categories of descriptors and have a predictor for each one. And then as a final step, we could try, as the standardized description is done to fit FoodX2 codification, to extend the process to the codifying directly into FoodX2. Thank you for your attention.
Thank you. Thank you, Guillaume. Have a seat. Thank you so much. So let me clarify a few things. I was so nervous at the beginning, so I actually forgot the basic housekeeping rules. I'm sorry about that. Firstly, this is being recorded the same as every other symposium here, so I hope you all knew that. And we need to finish at 3. We have time. We will do all the questions after the presentations. This is in order to not have the presentations rushed. Instead, have the questions rushed, which is better. So, the next presentation, I'm going to need my little note here. If you have ever wondered why ANSYS has turned into being a data-driven agency, we have our next speaker, Alexander Walsh, who is working there as a data scientist. He's here to talk to us about one of the, I wouldn't say problems, I would say challenges with the standard sample description, FoodX2. So please welcome Alexander.
So thank you very much for the opportunity to present this session. Today I will speak about telomere activity that we submitted to EFSA, was accepted some weeks ago. This is about the use of large language model for automatic food codification. This is a project that will start next year with partners from Denmark, Germany, the Netherlands, and Sweden. This presentation has 3 parts. First, I will introduce the problem in the context of data readiness for artificial intelligence. I will introduce the method that we propose, and finally, I will draw some conclusions. So what is food codification? Food codification is to assign the codes for food description. For example, here for this food is the margarita ham pizza. We assign for some codes. One code for a base term, that means that it's a pizza, and similar with cheese, meats, and vegetables. Some code for descriptors. Here in this case, a ingredient descriptor that this pizza have hams and porks and tomatoes. So food codification transforms not structured data into a structured data that is homogeneous data. So data is ready for artificial intelligence algorithms. So normally the first stage of a natural language process algorithm, what to do is to structure data. Textual data is not structured, but the first stage of this algorithm is structure the data. But this requires a lot of data, the computational resource. So with data that is already coded in FoodX2, we can construct better algorithms using less data. Also, if a model predicts food codification, we can trust in this model to apply this model for other applications. But food codification is expensive, it's time-consuming. So that is why EFSA proposed a method for automate these tasks. It's the smart code application that predicts food codification from food description with an accuracy of around 83% for the base term and 87% for the descriptor. Related to this work, but in another context, advances we developed a natural language process algorithm for classifying food into 32 sectors, a sector of the visitor mass sector, with an accuracy of 95%. These 32 sectors can be divided in more specific classification. This is called families. There are more families, it's about 660 families, so a more specific classification. At France, but in another institute, at INTRA, they developed an algorithm that classifies foods in this more specific classification with an accuracy that is lower. This is because when we try to make algorithms for a specific classification, we need some more data for training and more computational resource. In the meantime, the large language model was training in a large amount of data. This models can be a solution for construct this model when we don't have a lot of data for make a very specific classification. And the natural language process field was see a lot of improvement with the emergence of a large language model. So it's natural to ask, maybe mandatory to ask, if we can use this large language model for food codification. Some capabilities of the large language model that we think we can use for good automatic food classification is the large language model are very good for understanding and generating text, summarization, translation, classification, entity recognition, relation extraction, codification. In all these tasks, large language models are very good. What we propose is have two parts. First is the choice of the large language model, and after the exploration, the development of this model. For the choice, we have today a lot of choice. Every week we have more choices of models. We have popular models like ChatGPT, Google Gemini, or Claude from Anthropic. We have an open source model like the Llama family from Meta, Mistral. They have very good models. And we proceed with a lesson learning of existing machine learning model for in the field of food, conducted with the EFSA and member states, is to see if we can find areas of improvement of this model using large language model to see there are problems using these models that we can fix using large language model. We need to evaluate key factors like with EFSA member states also, like the data privacy, resource requirement, computational costs, accessibility, language support, of course, and to evaluate the understanding of this model for in the field of food. With respect to this understanding of food, we propose a classical property development approach that is to work in the question that we pass to the large language model to give information to the model that to have a better answer. This question and answer can be sourced from data set from EFSA member states. I have one example. For example, for one product, this is a frozen organic potato wedge cooked with 6% extra virgin olive oil, a mixture of dried herbs. The idea is to ask of the model if it's able to give a food codification. The idea here is, the point is to try to analyze the answer of one selected question for the whole data set, or to take a sample of the data set to conduct an exploratory analysis of this answer. This, for example, is the answer of Google Gemini. The idea here is to analyze the answer of the model. We see that for the answer that this model knows what is the products, that the information that model gives about this product is very relevant to this product. The way the model is thinking is maybe similar to the way that an expert will make food codification for this product. We have, of course, a problem of hallucination here because the model gives a code that doesn't exist. This a code that are not in the food codification, but the point here is to analyze the answer of the question, not to analyze the final result. We can try another question. We have this problem of hallucination, maybe to ask to the model to define or to imagine a classification for this product to understand the answer, or maybe provide from real codes from the food codification. We will see it one example later. But when we choose the model, we can proceed with a classical approach for work with this large language model is retrieval augmented generation and fine-tuning the model. I will explain now what that means. Retrieval augmented generation is how the model gives automatic food codification. We provide the information that the model needs in order to choose the good code. We think that this could be very easy in this context because the hierarchical structure of the food codification. See, for example, for this same product, frozen organic potato wedge, we can ask in the question, we can ask of the model, providing the question some codes to choose with the English description. Well, the meaning of this code. We start with a very general classification of food. Is the first level of classification of this hierarchical structure of the food codification. Then the model will choose one or two relevant classes that we provide in the question. For example, the model could choose plant commodities, like very relevant for this product. This code will be classified in a more specific classification, this is the structure. So we can repeat with this question with these specific classes, work in this structure, three structure of the food system. Go from general classification to more specific classification. So to ask many questions to the model in order to have the base term and the descriptor. So we try here for this product, and Google Gemini gives this answer for the base term. It's a potato-baked product. We choose this code. We have another example here for raw organic strawberry. The model chooses from general to specific. First, this general term that is plant commodities. After that, we choose more specific fruits. Fruit uses as fruit, berries as smart fruit, strawberries and similar strawberries. So go from general to non-specific. Every time, every step we ask to the model, we provide the code that the model needs for make this codification. And we can do the same for the descriptor using the same structure. After this retrieval elementary generation, we have three possibilities. The model is good in terms of accuracy that we define a priori with some metrics and some levels that we define. Everything seems good in terms of resource for a model to construct a model that make a food codification. In this case, we stop the project here. We think we can construct a tool for food classification using this large language model. The second possibility is that the model is good in terms of accuracy, that the model understands very well food, but seems to be very slow or very expensive to use it for food classification. This is because we need to ask to the model several questions. So you see for the strawberry that we need to ask 6 questions for the base term, more questions for the description. So for one product, maybe we need to ask 10, 15, or 20 questions in order to have the complete codification. That can be very expensive or very slow. In this case, we propose what we call a Foodex code embedding, is to train a small model next to this large language model, where the vocabulary of this model will be the Foodex code. It will be aligned with this large language model in the sense of that the embedding, the representing of this code in this model will be very similar to the English description in the natural language, original natural language that we choose. And at the next this step, maybe we can get from this model a sentence and embedding model, a model that converts a sentence or food description in this case into vectors that can be used for other artificial intelligence tasks, like classification in other nomenclatures, codification in other systems, or data interoperability. And the third possibility is that the model is not very good in terms of accuracy. This is because the model maybe don't understand very well food. In this case, we propose a fine-tuning approach, is to retrain a large language model using a specific data, in this case food data, in order to have a better model for a specific task. I put an example of this paper. They retrain a large language model, the blue model, using only financial data. It gets a model that is better for a specific financial task. So what I would like to say in this presentation is that we need to ask if we can use a large language model for food codification. We need to select, to consider factors when speaking about using a large language model. We need to ask if the model understands very well food in order not to have a problem of hallucination. After we choose a model, we can proceed with a standard approach for construct a tool for food codification. It's all. Thank you very much.
Thank you, Alexander. So, we are exactly on time. Impressive. Now we're going to leave the floor open for questions. I'm not sure how we're going to do this. Do we have someone who can run with a microphone? So yes, question down there.
Hi, thank you. These are all great. One thing all of these have in common that's different than some of the other AI tasks is, in a way, it's a finite problem. Like, there's only so many different ways you could ask about a certain chemical. Like, you could always come up with a new one, but in theory, you could have just hard-coded, here's the 100 different ways someone has asked about this chemical. And I know the French model sort of takes advantage of that a little bit with the sort of going back and updating your training database. But how do you, for the other models, are you building this sort of almost search history as a first pass so that you don't need to rerun the same question again? Thinking if we did this over all of EFSA, just having one massive search history that could save time.
Alexander, do you want to go first?
So the question is if we can construct maybe one approach for all these tasks, or maybe one big model, or so.
So if someone asks raw organic if someone somewhere asked raw organic strawberry, and you give it a FoodX2 code, raw organic strawberry is now added to a list, just a hard-coded list of the food. So the next person, it doesn't need to go through the model again. It checks that database of known aliases, or however you would.
But yeah, when this food is coded in the food exists, and there is a lot of description that person can use it. So sorry, maybe.
I can try and answer from the Swedish perspective. So your question is basically, do we look at previous searches? And the question would be, do we look at previous searches that has been accepted as a right answer? Since this is a pre-study, we can only tell you that we have thought about that. We have thought about having some kind of reinforced learning. We have thought about it, but we have not built a design for it. And I feel that is your true question. Have you built a design for this kind of system, taking advantage of previously accepted answers? And I'm sure we will do it, but we haven't done it. Next question. I saw someone down there.
Yeah, thank you for a very nice presentation, all the three nice presentations. I have three questions. For this, I start for the second one. The model is specific also on the language. I mean, is specific on French language. So in case one wants to use, I'm Italian, have to restart from the Italian sentences, right?
Does it work? Yes. Okay. Yes, the final model that we are using currently is specific to the French language. But with the method, you could train a model specific to your language. But for now, yes, it's only taking French as an input.
Okay. While the third one, it seems to be starting from English language. I mean, you start from the EFSA FoodX2 terms expressed in English language. Am I correct? Is this the story of?
So normally with large language model, you can work in several languages. Okay. It's why maybe you can make the prompt in Italian. I don't know what model works with in Italian, but we know that in French it works also. So okay. This is the good for this large language model, no?
Last question, and I don't want to. Yes, are the facets considered in these outputs? I mean, a part of all the three studies. I mean, sometimes the final FOODX code is made by base terms and descriptors. If when you arrive to evaluate the correctness of the results, you are also considered the descriptor terms and not only the base term. Is for all the three studies.
Yes, for me, for the first step is the trigonometry generation. You ask one question for the base term, one question for all description. Yeah, because you do the same. You use this hierarchical structure, but you need to ask in a separate way. The first for the base term, and for the production method, or for the ingredients.
And sorry, I just think I should clarify for this pre-study, we are not looking at FOODX2, just the other terms, the other catalogs, what do you call it? The new word, the dictionaries, yes, the other dictionaries, because we already have great projects going on with the FOODX2, so we excluded that from our pre-study.
And can I just make one more addition? Your second question was about the language in the FOODX2. The FOODX2 is in English, so all of the EFSA the dictionaries are in English. If this has been a choice that someone has made, or if it just has happened, I'm not sure. But so English has been sort of the working language. But someone told me yesterday that actually translation is a solved problem. So I mean, maybe it doesn't matter. But there was a question down here.
Yes, you asked about if the facets were taken into account in the prediction. For the method we developed, we are only translating from a language to another, but the FOODX2 codification for now is done by ourselves, not by the model. The purpose is to standardize the text, then do the codification, so there's no output in FOODX2 for now.
I have a question about this impressive work on mapping into the FOODX2. And I wonder, or I would like to know about the non-successful cases. So you said it's about 80%, 90%. And I would like to know what are the 10% unsuccessful. Are they more about translation problems or problems that an object is not identified as an FOODX2 object? Because there's also another option that would be the FOODX2 business rules, because there are many of these FOODX2 business rules, which usually in the daily work are rather the problem. So you should get a right FOODX2 code, but then you get an error message and saying the formulation of the FOODX2 code is not valid because there's some rule forbidding, for example, primary commodities to be cooked or processed and things like that. Do you have an impression? Is it more about breaking rules, or is it more misidentifying the objects?
Yeah, not for the moment, because we start the project next year. But of course, there's a lot of things that we need to take in consideration, like this. At the moment, the model will only output FOODX codification without taking into account these restrictions. But we need to find a...
Yeah. I can just say for the smart coding app, this is always congruent with the rules, but it's failing to identify the objects. But maybe your colleague can also answer.
Thank you. My question also to the last presentation. Frankly speaking, I prefer much more the answer that you did to the Gemini tool without RAG, rather than the second one. But it's a personal feeling, no? A personal opinion. And the question is, the second answer was stick to the point with exactly the code due to the fact that you used the RAG for the LLM, or because in the prompt you put the word concise, giving me a concise answer? I don't know if it's clear.
I asked to the model to give a concise answer because these models are very verbose. So it could give a lot of information that I don't need in the answer. So this is part of the prompt development I want to develop. So to what information you need to give to the model to give a better answer, to have a lot of information. We don't use it for this codification. But I don't know exactly at the moment.
I'm curious if you prompt the same sentence with concise, without rag, if you get the same answer, the same concise answer or not.
Yes, if you provide the choices, the food codification, not for the. I think that yes, because you ask at the end for a tool, we don't ask to the model to give an answer. You to ask the model in a very specific format that is JSON format that you can use it for computer, because you need to automatic tool. So you need a format that the computer can read and to redefine the code and give that in an automatic way. We don't need to read the answer of the model in order to have the answer, the final answer. So at the moment you ask the model to give the answer in JSON format, I think the concise question is not important, but we need to test.
Yeah, I'm trying to go to the root of the problem, to defining it. And so I will go back to your presentation, that what you were explaining, the SSD too, and so there we have this data, how it has been structured. So we have the data element and the data structure. Now, then I come to all this control vocabulary and things where we have a lot of semantics, and that need the mapping. So we have a structure, right? And then we have asemantics that need to be mapped, yeah? And so this is a classical problem of the semantic mapping, which has been done in a different way, and there is a different approach for that. And now again, I see that, which I am repeating again and again, that we are just using a generalized model, throwing it everything there, and trying that the generalized model can give us all this solution. And why we are not looking to some of this semantic mapping approach? Why we don't go back to that and see that how it can be solved in a classical way? Yeah, and that may be the question to all of you. Try to understand the problem. What is the problem? It's the mapping problem, right? You all are trying to, so even the language is different. Again, you will be dissecting your term and then mapping to the EFSA code, right? So it's again the mapping. So whatever the way you want to see that, it's a semantic mapping. Why you don't think from that angle rather than just going to the LLM?
So everybody just is waiting now for an answer. The $1 million question. Who wants to go first? I want to go first. And this is going to be such a boring answer, because I thought I partly answered it. Because the large language models are that good, we don't have to go to the root problem. So it comes down to basically, actually, what it comes down to is how good do we need the models to be? Because were we aiming for 98, 99%, then we would have to go back to our basic roots and doing semantic mapping. I'm certain. But if we can accept that being 90% right is good enough and save a lot of money and save a lot of resources, most of us will make that choice because we have a limited budget, limited funding, limited resources. And I understand that this is a provocative answer, and I understand it's a kind of an offensive answer, because We are EFSA. We should be striving for excellence. We should be going to the root and giving the most exact answer. But sometimes we just need to be good enough. And I understand, I can see in your face, you're not happy with this answer. But this is the most honest answer I can give you. It's too much work and it takes too much time. So,
let me come to that,
yeah.
Yeah, so when you go at the entity level, so now the code that you have are the combination of the entities there, or the coding that you have done that. What you're trying to give the NLP, generalized NLP process model that understand the pattern of the entity here and try to dissect it and the map for me. Okay. Now that's not the human language. It's a code that we have invented and we have put it there. Okay. So now you're trying, and this is where the mistake you are getting. Maybe sometime they are not able to dissect your entity to map it properly. Now, but the coding that has been, and that's why I was talking first that you have already the standard. So it's the SSD2 standard, which has been a data and the elements, right? Data element, and has a pattern. So if you tell that pattern to the machine, then it can do the better job. Or you train your model, and this is some of the things that you are trying to do, that you train the model by matching with the French pattern, and then dissecting the word to word or entity to entity, and then matching it, right? So that is the one of the approach, so if you want to translate it correctly. So this is where I want to go. Now, if you go to the generalized model, which has been trained for the human language, like the English language or any language, then it's taking it that, and there is a chance of giving the error, because that's not trained for that code. Yeah? This is where I want to go. So it's a very simple problem, and we are giving to a very complex model to understand that, and then complexity just increase. This is where I want to, get the answer.
So I heard someone say SSD2, so I'm just going to go. So Alexander, please go ahead.
I think that the large language model give a facility that we don't have. So we need a lot of data to train models like that, specific for this task. Those large language models provide this problem of data. Otherwise, you do need to look for data and do a lot of work manually to construct this data. It is. For my case, for the food codification, what you have is a text description. The food is a text, right by a human. If we process that, is difficult if you don't have enough of data, because how do you process this data? How do you structure this data? For me, the problem is to pass from something that is not a structure, like language, natural language, that the information can be placed everywhere in the text, and to put it in columns. When you have the information in columns, that is pieces of information represent that and that and that, you can use models. Maybe you can construct the model. But how do you do that? You need, for me, you need data. Manually construct data. This is expensive or difficult.
Some of the data you already have, right?
Yeah. There is data you can use. Yeah, this is true, because it's data what is done manually. At the answers, many people work food codification manually, and that explains a lot of time and effort for answers, for example. But for future work, how do you won't go? You can go in this way maybe, or yeah.
We will talk more, I'm sure.
It's a very nice discussion, this one, because I'm very interested. I think that one of the possibility to also answer to this kind of question is to have, I'm sorry, maybe it could be a bad terms, is a validation. I mean, all your proposals should be somehow validated, how are good on doing this. At the end of the story, not say this road could be good or could be bad. At the end of your stories, the validation will provide us a good answer. And so I'm proposing, of course, for you to have such a kind of validation of which are the good results you have. And the second thing is just to take in consideration that many member states already have their database. They typically want to map, if we are staying with the map, with their already structured database to the structured EFSA database. So not always they are asking in a current language style, just asking something to ChatGPT. Okay, they need to map something that has already been structured.
Again, but for me, the problem is that the way we can describe food is very large. This is the problem that you explained. Many people can give the different description for the same food. It's the same food. Maybe this food is in the databases. Of course, we can use this previous word for make a task for this food. But at the moment you repair the food, this food is in the database already. But all this possibility that you can describe, you can give information you don't need from the information, you need to propose to process this data and to give in a format that your data, all data, recognize. I think it's not very easy to do that.
I can add something that, as I said before, in the pre-study on the data mapping tool, it was not actually the mapping that was the biggest problem, but finding the correct codes to map, because there are so many, and sometimes they are very similar. So something to help with that is what we are focusing mostly on in the data mapping tool.
Hello. I'm going to change a bit the topic. I'm sorry for that, but I'm curious about the embedding, this number coordinate vector number that you show. Actually, you use, I think it's a common thing, AI. Maybe I'm making dumb questions, but I'm still going to make it. But can you really derive a physical meaning or some real meaning out of these vectors, out of this embedding, these numbers? And can you make sense out of it? Or can you actually figure out if the model is doing something wrong just by checking these numbers? Or can you check the correlations, what terms are connected to what terms based on that? Can you actually, does it have a real meaning, these embeddings? And over time, are they changing? If you create these vectors again with your same model, David or Alexander, would it create the same numbers? Is it really objective? Is it really some floaty creation of numbers? And over time, it's going to change. The more terms you input within that category, cooking method or whatever, the more terms you add, it's going to, I guess, it will naturally separate these terms or categorize different. So how is this numbers? What does it mean and how does it evolve?
So these vectors are very large, no? A lot of dimensions. It's very difficult to analyze it, but there is word that make projection in 2 dimensions of this vector and see that related words are very similar vector. So you have a cluster for fruit, for example, and vegetables and other sides. So you see that there is a comprehension of the word, but it's only possible with a projection that a human can see, because this is a lot of dimension that you can process.
No, so sorry. And you were also asking, or I thought you asked, could it change? Could the embedding change over time? There are different embedding models. There are a lot of different models. So the Swedish pre-study used models from OpenAI, used models from Voyager, and used also open source models. So there are different embeddings models, and depending on the model you use, you will get different results. You can have specialized models getting one results. You can have broad models getting totally different results. So it depends also on what kind of embedding do you use, or embedding model. It makes a difference. So it's not always the same.
Thank you.
Thank you. I was wondering regarding the data mapping, when you started your project and when it will be available to use. And regarding the French study, I was wondering if it's not easier to do what the Portuguese project is doing, that is defining the correct terms in the formulary that are used in the field, instead of doing this kind of work. Because I think it's very difficult to train your machine, because people are normally using different terms all the way, and you are always needing to train your machine.
So if I can answer now, the problem you're talking about is concerning the data transmission. I mean, we are the final persons that receive the data in France, and we cannot directly act on what is done before. But the French ministries are trying to standardize as much as possible the data we can receive by putting categories and not letting the people send the free text. So we have a hope that in doing so it will ease the translation done by the model. But we as data providers for the chemical monitoring network have no means to act on how the data will be reported to us. That's why we adapted.
I'm in Portugal also responsible for reporting the chemical data to EFSA. But it's kind of an idea that's a good example, the ones that is made by ASAI in Portugal, because it will facilitate a lot that work. And I think it's a good solution, because I'm thinking that it's very difficult, because even the same product can be described of very many different ways, and you always being needing to train your model to accept the terms. And so I don't know it is easy. Just wondering.
Yes, that's why we developed the standardized language to help us with the structuration of the data. But as you say, there can be very different ways to describe one element. Yes.
Thank you.
Yes, and also the question about the data mapping tool. Well, actually, I mean, there already is a tool functioning now, the Sigma S. Now you can talk to Angelo over there if you want to know more about that. But our data mapping tool, well, we hope to sign a contract very soon for the development phase. And so hopefully in a year or so, we have a product that could be used for, something working that we can build further on. And in 3 years, we hopefully have a final product.
Can I adjust one more thing there? I just love adding stuff. So the plan for the data mapping tool is, as Frida said, a 3-year plan with expected deliveries every year. So in 1 year, there's going to be a basic version. In 2 years, it's going to be an even better version. And in 3 years, it's going to be almost a finished one. And also, the Sigma tool is actually handling the mapping problem you were talking about, because there are some member states who find it hard to map. But in the pre-study, the most common problem, and I mean by far, was finding codes. we have time for one more question. But there are no more questions. So thank you all for coming. And thank you, Frida, Guillaume, Alexander. And thank you for this. Again, housekeeping rules. The closing session starts 15:30 sharp, which means exactly 15:30. So be here 15:28. Be on time. Thank you.
Hi. Good afternoon, everybody. I'm here to open and guide you through the last session of the day, the last session of the whole symposium also. And what a wealth of information have we been exposed to, really. So I look forward to turn the recordings into transcripts, to use one or other AI tool to turn it into a podcast or something, go cycling and listen again to it and dive deeper in this information, in this wealth of information that you have available. So my name is Didier Velot. I work in EFSA. I'm heading a unit responsible for foresight, innovation, and knowledge management. And I will start here my session as being the chair of our panel, not the pair of our channel, of course, the chair of our panel. Then I want to introduce you Akos. Akos, I don't need to introduce, of course, we have seen him before. Akos is the chair of AGOT. And if I may, Akos, you are also the vice president of EBTC, the Evidence-Based Toxicology Corporation recently. And then I want to introduce also again Fabrizio Abinante, our head of data. And this is our panel, ladies and gentlemen. Akos, so what a day already. So, but can I ask you, looking ahead, what advancements do you see in the next 5 to 10 years? So what did you learn from those last 1.5 days? Did it change anything? What do you really see there?
Yeah, thank you. That's $1 million question in many ways. What will happen in 5 to 10 years? So there are maybe more answers to it, I think. One is that maybe starting from the more general things, how our food safety will evolve or food systems is like partly dependent on the things which we discussed today and yesterday on AI, on data, but also it's more dependent on other things which we don't have very much influence on, like all the geopolitical situations, socioeconomic situations, like legal and strategic visions of the EU. So I think they will have a more profound influence on our food systems, climate change as well, all the other drivers which are happening. So data and AI might solve some of the problems, might create some of the problems, but it's still, I think, a very, very, very big part of our future, what will happen in these realms, which we did not discuss yesterday and today. So this is something which I wanted to say, that this is, I feel certain about, that there will be a lot of things which are out of our hands in a way. If we concentrate more on AI and data, so this is my expectations and also maybe kind of a vision and a kind of an optimistic vision in a way, maybe too optimistic, that we still don't know a lot of things. And it's no surprise, we were discussing yesterday and today as well. We don't know very simple things like what is exactly our food composition, what molecules do we eat, in what concentrations, how they interact with each other. And this is just the food. Then we have the contaminants. Then there is the microbiome. So there is a huge complexity. And we just scratched the surface. And we now understand that how deep it might be. And we don't have even the data to answer this. So it's still, I think, one of my messages. And also, I think it was even on the last slide of the presentation of the first day, that we need to invest in data generation. So very simple exercises in like laboratory data, food metabolomics. We are still not yet there to answer many questions. So this kind of human expert curated knowledge generation or data generation is still an issue and still something which we need to invest in. And then maybe we could use and explore the depth and the possibilities offered by AI or data analytics. And then by this, I think we could arrive to a bright future when really algorithms, AI methods could assist us, experts, in delivering our science in terms of useful decision-making or preparing for decision-making. But we still need a lot to do. So what will happen in 5 to 10 years? I assume that these things will happen in parallel. So we need to invest in data generation, but obviously we need to use some of the data sources which we already have and some of the possibilities with the algorithms which are available to test how we can use them. But in principle, I would say that based on the presentations today, yesterday, that AI algorithms or AI methodologies are already here. So it's not a future, it's a current reality. And maybe there is a lot to develop still and to apply, but even now we could do a lot of fancy things which we do not do. Why? Maybe we will explore in the panel or during the next conference. But the methodologies are there, I think. They are improving and getting better and better, but they are already there. So we will be able to explore and to use them and to deliver better mechanistic understanding. How people will collaborate with AI, I still have this belief that, yeah, if it's a co-creation or we use AI methodologies as we use calculators, then computers, and this is another toolkit, maybe better, maybe more clever in a way. But still, it is our vision, our expert interpretation, which should drive the processes, and to use AI methodologies along, then we will be fine and happy. If we will look at AI that, okay, it will solve our problems without expert intervention, without human in the loop, or without this knowledge generation, interpretation, expert opinion, or domain expertise, then we could be going into wrong direction. But I think now we are in the time that these things are being decided, and the standards of how we make science are also being questioned now and decided. So my optimistic take that in 5 to 10 years we'll be happily collaborating with AI methodologies, having our humans experts in the loop, so using domain expertise and leveraging the power of AI where AI could excel, but also maintaining our hands on the process. So this is the optimistic take. I could have a pessimistic one as well, but I don't want to.
Let's stay with the optimistic. Thanks, Akos. Akos and Fabrizio, you're hidden, but I didn't forget you. Akos, as chair of AGOT also, the role of collaborative learning in the whole thing. The learning about models, about data, sharing models and data. So how would you see this evolving?
Yeah, thank you. These are the unsolved problems. So again, I think there are two parts to it. One is that what we do at the advisory group on data. So I think still that one of the key issues would be for AGOT still to make the connections, to build networks, to maintain these networks, share experience, share models, whatever we want to share. And this is still true. And yesterday and today, what was maybe not a big revelation or a realization, that there are a lot of things ongoing. Different universities, research institutions, private companies are doing a lot of interesting things which fall under AGOT remit, and we don't want to reinvent or redo all those things, but we need to be maybe more effective or efficient in spreading these experiences, and this is something which certainly we could take up and shall take up from these 2 days, that there is a power in this networking which we maybe were not exploring good enough for various reasons, but that's, I think, something which we need to do better. The other part of it, when you ask about collaborative learning, federated learning, data sharing from a technical perspective, and also going outside of this room, and we want to involve industry, other authorities, other entities, citizens in data sharing or model sharing. Now then we're entering the field of incentives and motivations and behavioral science, in a way, how to convince others to also collaborate, also open up, also share. And this is something which I have not very good experience with through different projects. And I think we had a nice discussion yesterday with few people at the bar. But one of the topics was exactly this, and we concluded in this discussion at the bar that, and this was my experience as well, that it comes down to individual people. When you want to convince others, you have to do a sales work, and you have to sell the idea. And many of us, including myself, is not good at it. So if we want to have industry on board, we need to approach every individual entity from slightly different angle to convince, find their personal incentives, motivations, why to share, or to impose through legal processes, but that's the other thing. So when it comes to that part, I think we still need a cultural shift.
Thanks a lot. I hear quite some concrete actions that can be taken also tomorrow already. So Fabrizio, can I address you? Because you touched it already yesterday, so what the next steps are. But given what you have seen and learned today, how would you update your next steps and what would your points be that you want to bring?
Yes, I mean, I'm really happy about the day half that we have all together. And the idea was really to share experiences and also to discuss together the opportunities and the challenges in using AI. As I said yesterday, now the plan is to, first of all, to prepare a report about the symposium, because not all of us were able to attend. We only attend some of the morning and afternoon sessions, so we will prepare a comprehensive report with all the different projects and initiatives we have seen. So this will be the first step. Then for sure we need to discuss now in AGOT what does it mean now, what we have discussed in the last couple of days. And yesterday I was saying that perhaps this will be discussed in the innovation subgroup, but I have to rethink and I have to, actually I think that from what I have seen, that I think we should have a discussion in all the subgroups, because AI is everywhere. It's in the way we use and we will develop tools, is in the way we do data management, data mapping. We have seen it in the ontology sessions, in the way that we are now discussing, how can we increase our capacity by upskilling our people, by sharing knowledge, but also by using the new person that we have, which is AI, and is expanding a lot, the possibilities and the capabilities also in the people, and I would call it people, AI, and capacity, not only people and capacity. Because, AI is really supporting us also in expanding our potentials. So indeed, we will discuss what this means in the different subgroups in AGOT. I think I'm a bit concerned about the speed of our initiatives. If I think about the presentation of this morning, where we have seen the historical progress of AI in the last 40 years, in the last year, and we are still discussing our project and our roadmap with a time span of 2-3 years. I think this is a bit a problem for me. We should be faster. And to be faster, we should also be faster in decision making, which is also impacting the governance layer. So I think, we have to rediscuss a bit what we have discussed in the last 2 days will impact the work we are doing in AGOT, but also in EFSA, because this is also implies how we collaborate with other agencies, with the Commission, and I think it was really helpful for me these 2 days to perhaps a way to rethink our roadmap overall.
Okay, thanks. Akos, you want to add something?
Yes, one thing maybe, the partnerships. So if we want to be faster, I think we need to explore how other similar groups of interest, and we know about Medicines Agency's similar initiative, a discussion group, also EBTC you mentioned. So there are many initiatives around which we could build partnership with, and maybe together we will be kind of faster, or at least learn from each other, and not to replicate things which we already have somewhere. So this is something which we had on our roadmap and have, but maybe it yesterday and today reinforced me that this is something which we maybe need to concentrate more on. Yeah.
Okay, thank you. I'm afraid this is the only time time that we have available for this panel discussion. I want to thank you, Fabrizio, for this discussion. Please. Leaves me to introduce to you the keynote speaker of this specific session. So at the end of the event, Paul Devalier, who is our senior digital coordinator. Although Paul, today you're wearing a different hat, or even different hats maybe. So please, Paul.
Thank you, Didier. They were probably right all along. I have given a number of seminar speeches like this over the years, and since 2016, I've always included this slide because, frankly, it just amazes me. Here we are. How lucky we are to be here. Here. Once in a millennium radical transformation. And we are expected to arrive at this singularity within 1 year, a decade. It's definitely starting to feel close. And when it comes to data, we are there, as I hope to impress you today. The chart shows the exponential growth of all information-based technologies. And the argument it makes is that we're approaching a time in the very near future where the capability of anything that is information-based, and today almost everything is information-based, is infinite. LLMs are Gen 4, within a year Gen 8, and at this rate of growth, within a few decades, dispute not the time but the direction. Our capabilities in genetics, biotechnology, nanotechnology, computer tech, robotics, it approaches infinite. So what does that mean for our old Enlightenment era concept of humanity? I mean, this singularity demands, at the very least, a political, ethical, legal, philosophical consideration. We are standing at the edge of a massive wave of disruption and transformation, and all of the digital forces are converging into a tidal wave of post-humanist adaptation. And the wave carries with it both utopian and dystopian possibilities, but neither vision is wholly right or wholly wrong. Regulators and risk advisors must engage creatively with these disruptive forces, balancing data and human judgment in unprecedented ways in order to guide us away from dystopian visions. The presentations from the last 2 days that I've really enjoyed, we've enjoyed together, have been about preparing ourselves for neither a perfect world nor a nightmare, but for a realistic future. A near future where AI is integrated thoughtfully to improve the effectiveness and the efficiency of regulatory science and risk assessment. But I asked myself during the symposium, what's the real difference between data and emotion, between human and machine, between science and art? Oops. This definition likely resonates with all of us. It speaks to the ideals that we associate with our work: knowledge, experimentation, precision, rigor, evidence. We like to think of ourselves as embodying these values for scientific excellence in our work in regulatory risk assessment. And here we have art. It's contrast to science. Art is about creativity and intuition, using subjective judgment to make sense of uncertainty and complexity. These are very different ideas from the structured, evidence-based nature of science. But before we dive deeper into this topic of data readiness for AI, I have a question for all of you. Which of these definitions, art or science, best describes the regulatory risk assessment and the challenges we face and work with daily? What does this new data revolution teach us? If I set up for you a question within this gap between two artificial dichotomies. The gap between man and machine is not simply about the count of neurons, billions in humans versus millions in AI, because that gap is closing as technology advances. But I would invite you to think about the gap between human judgment and AI algorithms as a difference in role. From the perspective of post-humanist theory, where will AI transcend current human limits? From a liberal perspective, how do we ensure that engagement with AI and data remains firmly rooted in the human experience? AI will close the gap in computational capability. It may even develop a psychology, but it will not fully close the gap in judgment, which is inherently human, artistic, intuitive, based on the experience of being a human and the co-creation between humans that comes from our human social system. Today and yesterday, we've learned how AI, through vast data sets and machine learning, can reveal patterns that we humans miss. It provides insights that are grounded in data, and yet it lacks the subjective, the intuitive and human elements necessary for dealing with uncertainty and nuance and semantics, qualities that I would call regulatory art. This gap between human judgment and AI's analytical capabilities presents two challenges. First, we must ensure that the data that we handle is fit for purpose. Algorithms must be robust, explainable, free from bias, fair. Of course. This is where the scientific rigor comes in. But the second challenge, which is perhaps more critical in my view, involves engaging in the human art of decision-making for humans. And this isn't just about data. It's about the social fabric woven by the internet as the defining force of the 21st century. Because the term social didn't exist in this way in the 20th century. Information and connections were more local, slower. There was no real global culture. However, machine-driven social dynamics are now a major force of transformation in our digital age and the main system of communication. Your engagement with this new form of social, the global, digital, interconnected society, is what will ultimately allow us to make a meaningful impact. By connecting data-driven systems with this broader societal context, we transcend the limits of analytics and begin to shape the future with both excellence and humanity. The new communication system, this new social, and it's a noun on its own, not an adjective, may appear to anyone who's on TikTok or LinkedIn to be the occasional or addictive exchanging of pleasant and unpleasant content and messages with close friends and random strangers, or it's a network meeting between food safety experts, focal point network, or the EU's scientific community, or even stretching it to the maximum, it's Western culture. That's not what social is in the 21st century. Not at all. The phenomenon of social, #social, is that it has created a massively distributed, simultaneous conversation around the globe. You will never be aware of exactly how every single text, word, search, like, swipe, query is affecting indirect dialogue between human and machines pretending to be human. And you and I may have had a social moment just now without ever knowing each other, without knowing that we've had an impact on one another. And this is how the phenomenon of post-truth is developing. This picture here is just a snapshot of a single distributed conversation happening in nanoseconds. It's from 2008, by the way. So the takeaway is that social is me or some version of me connected to 4 billion people continuously in real time. And all of that is compressed to a single data point of machine-to-machine communication. And all of those conversations between machines are part of a universe of AI-accessible data. The 20th century was dominated by a mindset that data needed to be categorized, structured, controlled. And the approach made sense. It made sense when dealing with small, manageable data sets. Structured data, organized into neat taxonomies and ontologies, allowed government and industry to function efficiently. However, in the 21st century, that mindset no longer applies because the rise of unstructured data generated by social and sensor networks and digital interactions, high-volume transaction systems, has overwhelmed traditional systems of categorization. Instead of imposing order on this chaos, we must shift toward interpretation, which is a much more fluid and creative process. AI and machine learning are essential in this new paradigm, not because they categorize data better, that's impossible, but because they show patterns and probabilities. The task is no longer about structuring data in advance, but allowing the AI to navigate vast amounts of unstructured information within an exploding universe of untrusted and unconventional data and reveal patterns that we could never foresee. This isn't just a technical evolution, it's a philosophical shift. It calls for a different role for humans, one that's less about controlling data and more about interpreting it artistically. Our role becomes that of curators using intuition, creativity, and judgment to understand what AI uncovers, from being gatekeepers to becoming gatekeepers of structured and containable data, to being facilitators of possibility within the unconventional, allowing data to shape its own connections and grow on its own. I mean, in short, the future of data is not in imposing rigid structures, but in releasing data to speak for itself. Our task is to interpret, create meaning, and curate the insights that AI brings to light. Now, I struggled for days to develop a way to impress you with how far we are into this singularity of data. I found this: all the print that we've ever produced, from the Library of Congress to every magazine and newspaper ever printed, is around 0.01 zettabytes. It's the new measure of data. It's 21 zeros. Next year, we'll talk about yottabytes and then about brontobytes, and every word ever spoken by our human species at 16K, 16 hertz, that's 42 zettabytes. The universe of data to which AI has access, that's 367 zettabytes and growing exponentially. And last year alone, 120 zettabytes of new data entered this universe. AI lives here in the yottabyte, where it grows and thrives. It withers and dies in the 0.01. I think our colleague Tome Eftimov made the point yesterday during the Q&A. In the era of big data, the sheer volume, variety, and velocity of information make the 20th century method of structuring data to figure out the true nature of reality obsolete. And we're now faced with multidisciplinary, complex, and unconventional, again, that word, data sets that are so vast and interconnected that any attempt to fit them into rigid, predefined categories results in lost potential and inefficiency. So let me now be blunt. Ontology and epistemology aren't dead, especially, for example, in the biomedical sciences. They're still critical today. But walk with me a few years into the future. I have my doubts, at least as far as defining ex ante the creation of knowledge versus using them for what's profoundly human, non-mathematical, to explain knowledge ex post. And this is not a problem, it's an opportunity. Because the real challenge of big data is not finding a way to impose structure on it, but to interpret it. It's not about categorization, it's about connections and correlations. And the insights that truly matter are the ones that AI helps us find in the chaotic, unstructured flow of data. I'll say it again. Our role is no longer to act as gatekeepers of information, but to engage with the system of human communication, interpreting the patterns, the relationships, and meaning that emerge from this ocean of data. The real TOX data is not here. It's in the 367. The real food consumption data is in the 367, measured by phones and RFID chips and guided by the influence of social. It's also where all the open science data is, if we put it there. Facing that, data collection and validation procedures will fail, just like agrarian-era pitchforks cannot feed the planet of humans today. There's only human intuition and creativity that can turn information into relevant insights, and we should embrace that. This is the beginning of a revolution like we've never seen. It's a scale beyond scale that makes the agrarian revolution and the industrial revolution little pops. And if we recognize that we're only at the start then of this revolution, then realize that the 367 is like the steam engine, natural gas streetlights. It's Baroque 19th century steampunk. And the whole of the 20th century, with all of its horrors and miracles, is about to unfold in front of us. So as we look toward the future, our success won't be measured by how well we categorize information, but by how effectively we interpret the story that it tells. It's about engaging with social systems of communication. In classical liberalism, human identity is central. Yeah, it's holistic, the human being. It's this concept, the human, to which liberalism attaches rights. And one of the divine rights is the right to impose order on the universe, on nature, on the world of machines and data. But today, in a world shaped by the nexus of technology forces, AI, mobile, social, human roles are no longer fixed. They are ephemeral. They're constantly changing. And these roles produce data self-referentially, allowing machines to interact with trillions and trillions of data points to influence the social and psychological systems we once thought of as uniquely human. Anthropos. This shift has profound implications for societal transformation, because as roles become fluid and human-centered, frameworks, the human-centered frameworks erode or even collapse. And we have to lean towards a post-humanist perspective here, I think. Liberalism's foundational belief in a society centered on the individual and communication independent of machines is increasingly challenged. At the core of this change is the realization that there is no single object or truth, no thing. At the bottom of our systems, only relationships and interactions and statistical correlations. Our history, whether built on empiricism, where we touch and feel the world, or rationalism, where we think logically, now faces a new reality shaped by big data, this vast, invisible network of communication systems. And as we move towards a future where psychological and societal systems are increasingly driven by non-biological entities, which can think scientifically 1 billion or 1 trillion times faster, we need to reposition ourselves in this new discourse. The discourse that's too fast, too abstract, too large for traditional human scientific frameworks to fully capture. Even more so as machines now become the bedrock and possibly even the driver of the psychological and the social systems of our world. Enough philosophy. A simple metaphor. I hope to have painted a picture of the traditional scientific approach as one that finds the few coins of evidence inside a glass of disordered water. With a 0.01 zettabyte single glass, a systematic approach, traditional methods, traditional data management, yeah, that's possible. But not in this vast ocean of 367 zettabytes growing exponentially, where AI is almost genetically more adapted, like the first mammals in that cold, oxygen-poor world at the end of the Mesozoic era. We must change our approach, embrace our humble humanity, our daring spirit, our fierce and opinionated judgment, and learn how to sail across the sea as stubborn and brave explorers into the unknown, the untrusted, the unconventional, the dangerous. And really, I beg of you, please, against the reality of our new universe of data, let's not be those humans who fear the sea, who comb the beach, filling up glasses of water along the shore to bring back to the lab for our study and curation, ignoring the vast ocean from which the glass of water was drawn. So let me close now with 3 practical recommendations that I think support the arguments of the speakers that I heard at the symposium. And I love science, okay? I'm not giving up the ghost, but I think our role has fundamentally changed. So stop trying to control every parameter of the data analysis on only trusted data sets. Trust AI to handle the heavy lifting and focus your energy on interpreting the patterns of data in ways that are nuanced, ethical, and human. Trust is earned. It's also extended. Social beats authority. Point 2. And I know this is provocative, but I truly passionately believe that truth seekers, scientists, the authorities of our social landscape need to take a position from within the ocean of influence, instead of maintaining a superior position above it. Because the power of authority, long held by science and expert in government during the Enlightenment, which, by the way, ended in 2012, is increasingly overshadowed by the influence of digital networks and their new social systems. Traditional authority structures are being eroded by chaotic masses of interactions, bots, and influencers, and fragmented narratives shaping public opinion more than any expert voice. So engage with the social system. Influence today comes from within, not from above, because the reality of the 367 is that you are just another data point within it. Instead, engage in the dynamic dialogue where science engages with public discourse, navigating the chaos of social interactions. AI-driven social can help you understand how narratives are shaped. It's about participation, not proclamation. So tailor your message to the dynamics of social systems and the real-time flow of social interactions. Think of the public perception as an ever-evolving conversation where authority comes from being embedded inside the network and not standing outside of it. And finally, educate. If we can embrace that role and engage as humans, humble humans, in the face of AI's tremendous scientific power and big data's tremendous scale, then I hope I can also enlist you into the role of interpretation and communication as education. Look, the name of the symposium is about data readiness for AI. But what I learned from these last 2 days is that maybe the data is already ready. And the AI, little baby, steam-driven AI, is eager and hungry. It's people readiness for AI that is the key concern, I think. And Dorte, this is actually a recruitment pitch for your subgroup, right? So we've talked today about explainable AI, fair AI, but is it the role of AI itself to explain itself or know that it is reflecting our society's bias? Or is it our role? We're both parent and child in this new world, educating machines in ethics and human values instead of controlling and regulating it. This little baby AI that someday soon will be a very, very big adult. Do we want a bratty teenager under parental yoke, or a fully realized adult, ethical and mature to stand with you as partner? Which approach works best? So use your human strengths, insight, intuition, and creativity to guide AI applications and to add layers of meaning that machines alone cannot achieve. And then back at home, let's be more human. Now, foster a creative culture, shift the focus of scientific teams from rigid procedure to innovation and exploration, encourage experimentation, storytelling, and visionary thinking in collaboration with other humans, educating ourselves through true human social communication systems, such as this one. I learned a lot in the last 24 hours. So thank you for your contribution. I want to thank all the speakers for the excellent contribution, as well as to you, all participants, without which a symposium like this would just not be a success. And I look forward to what we will create together in collaboration at the start of this new revolution. Thank you.
Thanks a lot, Paul. Thanks a lot. You were wearing your post-humanism hat?
Yeah.
Today. Okay. It leaves us some room for some, let's call it, I mean, you give us quite something to chew on, to digest, so to stay in the digestive system. So any gut feelings that come up, any questions that you want to ask to Paul, any remarks that you want to give? These, the gentleman with the white shirt.
Would you be able to reiterate what you mean when you say social?
Hashtag social.
Yeah.
Yeah. So sometime in the early 2000s, social media and the interactions across a global community congregating around the internet started to create more machine interactions that were invisible to the actors in that system, the clickers, the swipers. And so that started with algorithms and large data sets from the Microsoft, the Facebooks, the LinkedIns, to create a dialogue between machines that started creating that 367 zettabytes of data. And so social is this noun I refer to because I myself, I go about my day, I go to sleep, I wake up, I do some things, but there are many, many versions of me that the machine, that data set, is always trying to figure out and predict and anticipate. Most of the data, or a very large part of that 367, is that. And that's what I call social as a noun. It's driving the creation of data and the prediction of humans. And I think we need to take stock of that. I hope I've
Yeah, no, that's
answered
perfect.
you.
That's my question. Thank you very much.
Be first.
Thanks so much, Didier. Paul, you said that in approaching to the end of your presentation, that was great, that, okay, let go, stop, try to control everything. We see grow AI from baby to adult, but and to adult with education, ethics, but if this baby grows so fast and pass directly to the adult phase without teenager phases, leading with restrictions, to the frustration, to the limitations, how we will deal with this so specific adult?
Exactly, that's the question. I'm anthropomorphizing AI when I say it lives in the 367. And we, I think, too often are feeding it 0.01, but it's whether or not we're regulating it or not, it's out there anyway. It's learning. It is growing. It's an unstoppable manifest destiny that these systems will become so vast, and we have to figure out a different way. I don't think we do that through the traditional approaches, but I don't have the answers. I would like the next symposiums on data, on AI, to explore that in a lot more depth. And I think that's where the innovation subgroup and the people and capacity subgroup are excellent places to guide that discourse, that discussion.
Yeah, thank you, Paul, for the presentation, and also a lot of thoughts started to bounce in my head. And I just came across an interview of Terence Tao. He's a mathematician, one of the most famous mathematicians of our age, on AI. And he also said something along the lines that AI is very good in processing huge amount of data, and humans are very good at deriving insights from small amount of data and to be very creative. And this is where mathematics is supposed to further develop. And my question is, how are we sure that AI is not becoming creative? What is this hubris in our head that we think that it stops here, it is good for large amount of data, humanity is good in creativity and interpretation. There is no physical boundary, according to current knowledge, for AI to develop to an extent where it becomes creative, just to further induce thinking. What is your take on that?
It's a personal take, because I think we've all heard and read the experts who are in a utopian or a dystopian view of that same question, Akos. I think personally, we tend to, I think now of the movie Alien, it's still humanoid. Now, we have a lot of trouble as humans thinking about something being fundamentally different in its building blocks. I like to think, therefore, personally, that creativity is something unique to our species and is not only is it not shared with AI, it doesn't need to be. It's a different intelligence. It's a different form of intelligence. And I think this universe is made richer by different forms of intelligence and diversity rather than applying something fundamentally human to them, to algorithms. But it's a personal view. It'll play out.
Okay.
Thank you, Didier.
Thanks a lot,
Thank
Paul.
You all. Was not
Thank you very much.
Q&A.
This brings me to the official closure of the symposium. And to close, I want to circle back a bit to also what Nick was talking about in the beginning, data. So data, I mean, data, we all knew data, of course, because data, the word data comes, of course, from here. And what you were referring to also, Akos, in your last intervention also, and what Paul was saying there, so there's this, why don't we ask our only one general post-singularity AI, we have access to data, what he thinks about it. And I'm superior, sir, in many ways. But I would gladly give it up to be human. So here, please also link to what was said before, our creativity. I don't know, the discussion is about AI can be creative or not. We climb a mountain for no reason. Our sense for exploring, just to be it, to see it. We love, we feel compassion, we feel anger, we can hate, we can kick out of frustration, all these kind of things that AI or general AI also for sure won't be able to do. So we have a role together. So the future is, well, let's use the time that AI gives us to be more human. And I would like to close with this, and I would like to talk, I would like to thank, of course, all the speakers, all the chairs, the panelists, the rapporteurs. I would like to thank the organizing committee, the scientific committee, but also the technical assistants. I would like to really thank everybody there, but most of all, I would like to thank you, the humans, and us. Thank you. Thank you for this. And few housekeeping, it's not housekeeping, it's just some messages. So the slides will be published. So unless anybody has any issue with this, but normally it should not be, it will be happening very soon. You will be sent an evaluation form also very soon, so please compile it. We can only learn from it. And staff also will be available in case you have any question on your travel home. So thank you. Thank you for everything. Safe travels and see you soon. Stay in contact. Bye.